Hi and welcome. I'm Awais Mughal and we'll be discussing about the front-end testing today. I'll be using React code examples to elaborate the concepts, but the concepts are not limited to just a single framework. You can adopt them to any framework that you like or you are currently using. So if you look at the subheading, you can see why, how, wow, wait, okay. So these are the emotions that you are going to experience throughout this video. So enjoy. Um, let's see what is the goal of this video. So one of the biggest challenges people face when testing is knowing what to test, right? The goal is to show you good practices of front-end testing that will make yours and your colleagues' life easy. The goal is not to teach you test-driven development. In fact, you don't need to know what is test-driven development to understand these practices and concepts. So let's move forward. So the first concept and the question, very important question is, should I test implementation detail? But wait a second, what is implementation detail? Right, simply put, implementation details are things that users of your code will not typically use, see, or even know about. But to understand this better, let us go through an example. As you can see this code right here, if you're wondering why I'm using class component and not function components with hooks, it's okay, just keep on listening. It's an interesting reveal with some of you, actually those of you who experience with enzyme you might already be expecting, but if you're experienced with enzyme, yeah, but if you're not experienced with enzyme, you will still understand the reason behind this. So according to this code, you will be able to open one accordion at a time. Uh, so I've already written the test for this accordion, and you can see here's the test implementation detail. Uh, so let's look at how things break down with these tests. But the thing is, a good number of developers find testing distasteful, right? Especially UA testing. Why is this? There are various reasons for it, but one big reason that you'll hear again and again is that people spend way too much time babysitting the test. They would say every time I make a change to the code, the test break, and this is not good for productivity. Like these sort of excuses or things you can hear from people. But we have to look at how our test falls prey to this frustrating problem. Let's say I'm refactoring this accordion to prepare it to allow multiple accordion items to be open at once. A refactor doesn't change existing behavior at all. It just changes the implementation, right? The focus is on implementation. So let's change the implementation in a way that doesn't change the behavior. Now that we are working on adding the ability for multiple accordion elements to be open at once. So we're changing our internal state from open index notice to open indexes, right? And that's good. Like we did a quick check in the app and everything's still working properly. So when we come to this component later to support opening multiple accordions, it'll be easy peasy lemon squeezy. I mean, then we run the test and boom, they're busted. Like which one broke? I mean, set open index function sets the open index state properly. So what's the error message? Let's look at the error message. Is the test failure warning us of a real problem? No, the component still works fine. I mean, so this is called basically a false negative. It means we got a test failure, but it was because of a broken test, not the broken app code. But okay, I mean, let's go ahead and fix our test. So now we have refactored our test and it works just fine. But the takeaway from this example is the test implementation detail can give you a false negative when you refactor your code. This leads to a brittle and frustrating test that seems to break any time you so as much look at the code, right? So, but I mean, let's go ahead and look at another scenario. You have, let's say, that your coworker is working on the accordion component and he sees this code. Immediately, he says, okay, there's some performance optimization that we can do. And they say to themselves, hey, inline arrow functions in render are bad for performance. So I'll just clean that up. I think this work should work just fine, right? I'll just change it real quick and run test. So that changes to they remove the inline arrow function and they run the test, and the test run just fine. Great. I mean, it's just working fine. There's nothing breaks, and they commit the code without checking it in the browser because that's give you confidence, right? The commit goes into a completely unrelated PR that changes thousands of lines of code and is understandably missed. The accordion breaks in production, unfortunately, and your team feels horrible. But what went wrong? Didn't we have a test to verify that the state changes when open index is called and accordion content are displayed appropriately? Yes, you did. I mean, but the problem is that there was no test to verify that the button was wired up to set open index correctly. See, that was the issue. And this is called a false positive. It means that we didn't get a test failure, but we should have. So how do we cover ourselves to make sure that this doesn't happen again? We need to add another test to verify clicking the button updates the state correctly. And then I need to add a coverage of threshold of 100% code average so we don't make this mistake again. Oh, and also I should write a dozen of ESLint plugins to make sure people don't use these APIs to encourage test implementation details. But I'm not going to do that. That's a lot of work. I mean, I'm just so tired of all these false negatives and positives. I'd almost rather not write tests at all, right? Delete all the tests. Wouldn't it be nice if we had a tool that had a wider bit of success? I mean, yes, it would. And guess what? We do have such a tool. So let's look at how we can save ourselves from this bit of despair. Okay. So, I mean, we can rewrite this test with Enzyme, limiting ourselves to the APIs that are free of implementation details. But instead, I'm just going to use Reg testing library, which makes it very difficult to include implementation detail tests in my tests. Okay. Since the APIs for implementation details testing are available in Enzyme, we are going to avoid it because it is very tempting for newcomers to implement those APIs. And if you're not using React, you can simply search for DOM testing library or check out the link for it in the description. I think I will give it to you guys. So now look at the test. A single test that verifies all the behavior really well. And this test passes whether my state is called open index, open indexes, or shawarmas are tasty. I mean, it doesn't care. It really doesn't matter. And got rid of that false negative, right? And if I wire up my click handler incorrectly, this test will fail. So we got rid of the false negatives, false positives too. No, sorry. And I didn't have to memorize any list of rules. I just use the tool in the idiomatic usage, and I guess get a test that's actually gives me confidence. And my accordion is working as the user wants it to. So the issue of testing implementation detail is resolved. So let's iterate over what the implementation detail is. Implementation details are the things which users of your code will not typically use, see, or even know about. But who is the user of this code? And this question is a very important discussion, which we're going to have right now. And that is, the topic is avoid the test user. But I don't know about the users involved with this code. I mean, generally when you write UI code, you have two users, right? The end users that is the end user that is interacting with your component, and the developer rendering your component, right? So let's imagine you have the following UI. The form component here is called user settings. The component exposes a certain API for the developers rendering it, and the users using it. The first user is the end user. When the end user changes one of the values in the tagline or the biography, the reset button and the submit button, the click icon where you can see, becomes enabled, which are currently disabled right now. So when they click the reset button, the form is reset, and when they click the submit button, it saves the user info. It also shows the loading state while we wait for the request to finish. But the second user is the developer user. They render this component within a user provider component. So the component can access and update the application user state and dispatch which is stored in either React state or in React context, however you want it, right? But what does this have to do with testing? I mean, why we're discussing it? The important thing is the more your tests resemble the way your software is used, the more confidence they can give you. So knowing how your software is used is really valuable. It gives you a guide for knowing how to test the component. But far too often, we see tests which are testing implementation details. When you do this, you introduce a third user that we're going to talk about. You see, in the previous example, we saw the implementation. So we saw the test with the implementation details. Now that as soon as you start testing things which your developer, user, and the end user don't know or care about, which are implementation details, you add a third user. You're now having to keep that third user in your mind, right? In your head. Every time you change your code, you have to change your test again, which makes you account for changes that affect the testing user as well. And for what? To get confidence. But what are you getting confidence in when you test things this way? When you test things this way, I mean, you're getting confidence that things work for the testing user. But nobody cares about the testing user. I mean, the testing user doesn't pay the bills like the end user. It doesn't affect the rest of the system like the developer user, right? Um, and I mean, that accounts for this current topic. So let's move on to the next topic, which is a very important question, like should I test child component, parent component, or both? So now so this is all about trade-offs and realizing that 100% unit and 100% integration testing or coverage is really not possible and often not necessary. The idea is where do you get the most bang for your buck in terms of confidence that your application runs as expected. So if you want to duplicate efforts across tests, you can go ahead. But let's look at the example, the next slide. And here's a parent component which renders a child component and passes down the props. And here's a child component which just renders a button and props pass down to it, right? So let's look at the test for the parent component. So here's a test for the parent component, and you can see we are also testing the child component, which is the button being rendered in the parent component. Also note that we didn't specifically write a test for it, which means that there was no need for us to write test separately for the button, right? But if we were to write down the test for the button component, it would look like this. Okay, look at this. Just as the parent component test, we are testing the click event for the button, which is actually a duplicate test. So the question is there any need for us to write tests for child components when it is being duplicated? The answer is that it all depends upon the child component. If the child component holds a business logic that is internal and is not being manipulated by the parent component, then it is a wise decision to write a unit test for the child component. Otherwise, if you are writing a test of the parent component and the child component is also being tested completely, then there is no need for us to write a duplicate test for the child component. Let's look at the child component again, okay? Look at this here. There is no business logic in this child component, and it is also being tested by the parent. So, which you can see here, right? So I don't think there's any you can like if it's already being tested here, then there's no need for you to write all those separate things. So let's conclude this video, what we have learned, and that is writing tests that include implementation details is all downside and no upside. Focus on the developer user and the end user, and your tests will actually give you confidence that the things will continue to work for them, right? And when your test break, it becomes a cue for you to know that you have other changes to make elsewhere to account for the changes you've made. Avoid testing implementation details and you'll be much better off. And use DOM libraries to avoid any urge to do implementation details testing. In case of React, use the pre-packed testing library. I think it's just DOM right now. And it's a good idea to keep the unit tests at a higher level as much as possible, right? But if you want to duplicate the efforts across the tests, Go ahead, it's all up to you. Thank you for watching. Kindly like, subscribe, and share. And if you have any feedback, kindly let me know in the comments below. Thank you.